Hi there, I'm John from CNCKing.com, and today we're making a custom stereo bank. Before I ran a custom manufacturing and fabrication business, I taught myself how to design, and part of that was giving myself projects to try to think through things. And this is one of them. It's a stereo bank that I designed, I think over 10 years ago. And what it is an idea of a place to store lots of money and stuff in plain sight, so that nobody really notices, but you can hide lots of stuff in it. So for instance, here you have the speakers, and you say, oh, that looks kind of cool on a shelf, but you can actually put your money in through the top. And if you're wondering how to get their money out, you can either flip this around, or you can actually just lift up the back, and all your money and valuables are there. So the other speaker is identical to this one. It's two identical models. And this one here, I just took the back off for speed. This is the front of the stereo, as you can see here. And in the back you have, again, tons of storage. So if you want to put money in it, you can actually just put it through here, or you can put it through the top. You have the little holes here for other kind of things. So the idea behind the stereo bank was storage in plain sight. And I always think if you want to hide some valuables and stuff like that, put it right in front of the people and they will never notice it. I notice that at a lot of craft shows, if you put stuff that's very valuable right in front, it just goes right over people's eyes. People can't believe that you have tons of stuff of value right in front of them. I really enjoy the power of 3D animation and 3D modeling for making this stuff that I do in the shop. It allows me to preview and pre-build everything virtually, which means that I don't waste any machine time or materials actually testing out a design. In this case here with the stereo bank, everything fit perfectly. There'd be a couple little things that I'd improve upon here and there, but nothing major. The overall structure fits and worked absolutely perfectly. Now you have to keep in mind, whenever I design these things, always based on the material thickness. So for instance, this was designed to be 1/4 inch material, but if the material, let's say, happens to be a 1/2 inch, well then all I have to do is, double the scale of the design, and I have 1/2 inch and everything fits perfectly. It's a non-parametric way of designing that I taught myself. It actually works really, really well. It means that I don't have to keep exporting design files to account for thickness. All I have to do is just scale it to match the thickness, and everything fits absolutely perfectly. So part of the fun of teaching myself how to design these kind of projects here was also how to teach myself how to make animations of said designs. So that's the other part that I really enjoyed about this process. And this is actually the first time I actually cut this thing out and assemble it. And everything works totally fine, which is kind of impressive considering how many parts there are and how many parts are interlocking. Now the interlocking is a very important part because that means that everything is supported by something else. So I was able to assemble all of this here without any glue initially. Just to make sure the fit, everything worked properly. And then when I added glue, it just made things that much stronger. Something I like about this design is the layering that I accomplished. So you can see here, I could have made this all with one solid piece and laser engraved it, but instead I made little parts like this, and of course little parts come out, which makes it kind of fun. Little parts actually move around. And the top also comes up. So it's like a real stereo. Now the difference in material, I could have cut this out of plywood, I could have cut this out of corian, I could have cut this out of steel. It doesn't really matter. The only thing you got to keep in mind is cost. Doing it out of MDF, this is 1/4 inch, is a lot more cost effective than, let's say, plywood or stainless steel, for instance. When it comes to actually fabricating out the parts, it's a relatively straightforward export. So I have a 3D model made up of 2D parts, and I just make that flat, and then I export to the format that the laser enjoys using for the cutting process. Now the laser here is definitely sped up because you don't want to watch a very long video of this laser cutting happening. It's 1/4 inch MDF, but the process would be identical if it was 1/4 inch plywood or 1/4 inch veneered MDF core or 1/4 inch acrylic or 1/4 inch whatever material you could think of. And of course the scale goes up and down based on the material thickness. This one here, the MDF was 6.5 millimeters, so it's a little thick, so it's a little bit more than a 1/4 inch, so I just had to scale my design up 10% and everything fit absolutely perfectly. Now the laser, what it does is cutting all the inside parts first, and what you'll notice is here you have a speaker, and the inside of the speaker has really nothing, it's not a valuable part for anything, it's just scrap. So I might as well use the inside of inside parts to cut out other parts, therefore I'm not wasting any material, and it makes things very straightforward when you're assembling. And you also notice that it's also not cutting straight lines all the way across for some of these parts, and that's because I'm using a shared line. Again, something else I taught myself just to bring costs down for production. For a laser, it's pretty straightforward. If you go over the same place twice, well, you've wasted, you wasted 50% of your time and 50% of the resources of the laser and so forth. There's no reason for it. Once the laser cuts, it's done. If you go over the same cut area twice, you're not actually doing anything really. The only thing you maybe causes more problems because you might end up with a fire or something like that. Because sometimes little parts fall out, and then if you go over it again, you create more heat and friction and all that kind of stuff. Anyways, so now what I'm doing is cutting out all the little holes for the speaker. I designed these models so that they can be done with a laser or a router. In this case here, if I was going to do it with a router, you notice a lot of the inner parts are sort of square, and that's where the laser sort of shines because it doesn't have a spinning bit that I have to account for. A spinning bit has a diameter, which is a circle. And the problem with that is for inner parts, if you have a square 90-degree angle, I don't know how you do that with a round bit. You just can't. So either you overcut it or you do dog bones or other sort of things to account for that specific cutting process. Now you notice just now at the top here, I actually didn't run the laser twice over the same area. And it's not a big deal because sometimes you just can't get rid of double lines. It just happens that the design there didn't suit more optimization. I do all this optimization manually as well. So I just go over the design because I designed it, so I know where all the parts are and how everything sort of fits together. I also know where all the double lines are, so I just manually go through it and just remove them. It's a pretty straightforward process. It's just part of the design process. But these are all little steps that I taught myself, again, just to optimize design, optimize and profiles and so forth when it comes to laser cutting model kits. Now, one thing I forgot about gluing MDF in this sort of kit format is that the glue really likes to stick to everything. And because MDF is a fibrous material, when you have glue on your hands, there's no way of not having glue all over your hands when you're doing this kind of stuff. And you touch other parts of MDF, your hands want to stick to that and you end up sort of grabbing a little bit of the MDF on the sides or other parts of the model. So things just start to stick to each other just because glue is very fast acting nowadays. Back when I designed this, 10, 15 years ago, I don't remember exactly, glue wasn't as strong as it is now. So I didn't have that many issues with it. Now, if I'm cutting out a model using plywood and I'm gluing it like you see here, it's actually the surface of it is a lot cleaner. So you don't end up with parts sticking to you and you sticking to the parts while you're assembling it. You also have this issue again when you use clamps because the clamps end up having glue. And when you glue things together, it sort of seeps out on the edges, as you can see here. And when you take them off, they're glued to the part. And with plywood, it's not as much of an issue, but with MDF, it's definitely something. Now here, you can see I'm building up the speaker. And I had a little bit of trouble on the corner things that you see that hold the front of the speaker and the sides. I designed this a long time ago and I never made a physical model. This is the first time I make a physical model of my design. And because of that, I didn't account for some little tweaks that would make the design process easier. Because whenever you have a sharp part and it has to hold another part, you want it actually to be square. And the reason for that is because it gives you more surface area for glue and more surface area to hold everything together. Now the actual stereo itself came along very, very well. I was actually quite surprised with that one. Sometimes you think more complicated parts are harder to build together. And in this case here, it actually wasn't. It was actually easier to build the stereo main component than it was to build the speakers because you had more interlocking parts. Again, when you have parts supporting other parts, it makes assembly so much easier because the model holds itself up. So if you're looking for custom banks, any size, any shape, any material, any design profile, head over to sandboxranch.com. There's a whole bunch of banks there, both in the laser cut style 3D dimensional like this here, and traditional, piggy banks like you had when you were a kid. Just go to sandboxranch.com. If you see something if you want something that you don't see on this website, just contact me and we can, custom fabricate basically anything you have in mind. From then on, make it for you and ship it right to your door.